Hey GED students, it's GED question of the daytime, and we're looking at another little brain teaser from Mashup Math. This one says, what is the value of the missing number? And you can see here, this time I just have a sequence or series of numbers. We start with the number 1, move on to 4, then 13, then 40, and I'm looking for some unknown number. So a lot of students, will start by trying to see the difference between each one of these. Like, how much am I going up or down by? And so certainly we could explore that. Let's give it a try. So if I wanted to get from 1 to 4, I'd have to add 3. 1 to 4. If I wanted to get there through addition or subtraction, I'd have to add 3. Then let's see what happens from 4 to 13. So 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's an adding 9 situation. Okay, if I wanted to get to from 13 to 40, what am I adding? Well, let's see. Adding 20 to 13 would get me up to 33, and then I'd need another 7 more. I'm adding 27. Now, a lot of students look at this and they're like, I cannot tell what the pattern is here. What is going on? Add 3, add 9, add 27. So I actually could establish a pattern from these 3 numbers, but it's hard for a lot of students to see. So this is what I want to point out to you. Do you see how the growth is changing? It's not like I'm adding 3 every time or adding 9 every time. I'm adding more and more each time. That's a really big hint that this can be thought of as a multiplication problem. Instead of trying to add a number, why don't we try seeing about how many times more we're looking at? Okay, so I'm going to look at this problem now a different way. Again, there's nothing wrong with this way, and I could even use these numbers to get to the next number. But I just want to say to you, like, adding's not the only kind of math we can do. So let's take a look. Now this, if you look at getting from 1 to 4, like 1 times what equals 4? It would be 1 times 4 equals 4. Okay, now let's look at the next one. 4 times what equals 13? Well, you notice that 4 doesn't go perfectly into 13, but let's try to get as close as we can. 4, let's see, 4 times 3 is 12. I'm pretty close to 13. I'd have to add another 1 to get to 13. Let's take a look at 13 times 40, or 13, how many 13s are inside of 40? Well, if I count by 13s, 13, 26, 39. Ooh, I can get real close to 40 again with 3 13s. 13 times 3. If I take that number I have, 13, and multiply it by 3, I'm really close to 40. I'm at 39. I would just have to add 1 more to get to 40. Interesting. I found the same thing twice. I found here that I could multiply by 3 and add to 1 to get to that number, but that's not what I did over here. But let's see if that works there as well. Let's take a look. What would happen if I took 1 and multiplied by 3? Well, I'd get 3, and if I added 1 to that, well, there you go. That does equal 4. That is another way to get from 1 to 4. So this is a complex pattern, what's going on here. What's happening? Each number is getting multiplied by 3, and then has 1 added onto that answer. So let's do that with the number 40. Let's take 40, multiply it by 3. I would get 120, add 1, and I'm up to 121. Definitely, I could do the math that way, and I would get 121. Very nice. All right, if you have any questions about this or any other GED math topic, be sure to drop it in the comments, and I'll do my best to answer it.